Now I'm going to talk about a structure called MOS. Those of you taking 323 right now, you should be going over this in class. So some of this might be a repeat, at least this first introduction lecture. Okay, so what is MOS? MOS stands for metal oxide semiconductor, and you might be wondering, okay, well, why are we learning about MOS right now? So the MOS structure is one way that you can make a transistor, and a transistor made this way is called a MOSFET, for MOS field effect transistor. We're going to be learning primarily about that type of transistor. Another structure is the bipolar junction transistor, or BJT. That was actually developed before the MOSFET, but it's used less frequently now. So we're going to learn MOSFETs first. And why are we learning about transistors? Well, this is really one of the most important semiconductor devices used in electronics. Almost every electronic device will have a transistor, and the reason for this is because we can create what a transistor does is it's a voltage controlled current, and so we can make things like electronically controlled switches for digital circuits. We can regulate current flow in analog circuits. We can use transistors to make amplifiers as well, in analog circuits as well. So all of these things correspond to things like CPUs, memory, displays, imagers. All of these are going to use transistors. I didn't write down amplifiers, but that is another application of transistors as well. So why these usages of the transistors and the function of a voltage controlled current source corresponds to the MOSFET, the MOS transistor, as well as the BJT. So why are we going to learn MOS first? So MOS, again, is the building block of the MOSFET, and the reason why we're learning MOS is because of how popular MOSFETs are. The reason why they're popular is that compared to a bipolar junction transistors, MOSFETs are smaller, they use less power, and you can make circuits that don't require resistors. You can actually use a MOSFET to make a resistor. And you might be wondering, well, a resistor is simpler than a transistor. Why would you want to make a resistor out of a transistor instead of just making a resistor? Well, when you're actually creating these resistors, that requires a different processing step. If you're making something with a very high resistance, but the resistance is it's a metal film on top of your semiconductor wafer, so that can take up a lot of space, whereas the transistor will be, or to make a high resistance, can be made much smaller. And one of the most important points is that it's very easy to make MOSFETs. That means it's cheaper to make MOSFETs. You can get more transistors per area for less money, and so there's a big economic driver for using MOSFETs. If you can make some electronic device cheaper, then more people are going to buy it, and that's really what drives the popularity of MOSFETs. MOSFETs are manufactured using something called the CMOS process. The C stands for complementary MOS. I'll talk more about what this means later on. But this is a very standardized fabrication process, and there's a lot of these factories that produce these devices are called foundries. So there's a lot of dedicated foundries for this CMOS process. If you make anything different from that, because it costs billions of dollars to set up one of these foundries, they're not going to want to make it, because these foundries are very specific to working with this CMOS process. One example is digital cameras. So when digital cameras first came out, they used something called CCD imagers, charge coupled devices. This actually gives you a better image, and they were developed first. So these were the first digital cameras. But later on, imagers based upon CMOS devices were then developed. They do use less power than a CCD imager, and they are a little bit faster, but they don't give you as good an image. They're not as sensitive to light as a CCD imager. However, the big driver here is that because they were made using a CMOS process, you can make them much cheaper. And so the CMOS imagers became a very cheap digital camera that you could put in things. So for example, the cameras that first started appearing in cell phones were all CMOS imagers, because that was the cheaper one.